Dear students, now I am going to explain about concentration cells. Here you need to study EMF of concentration cells and its application. One of its application is determination of solubility of sparingly soluble salts. Let us study about the concentration cells. Concentration cells are those in which no net chemical reaction taking place, but the reaction consists of transfer of material from one part of the cell to the other due to difference in concentrations. The difference in concentrations may be in the electrode material or in the electrode itself. Number one, in electrode concentration cells. So it is the first type of concentration cell. In electrode concentration cells, the electrode material involved has a variable concentration like amalgam electrodes and gas electrode and also hydrogen electrode. The best example is the hydrogen electrode can be set up by maintaining two different pressures of hydrogen gas. The first of cell of the hydrogen electrode is set up by bubbling hydrogen gas at at P1 pressure, atmospheric pressure, which is in contact with hydrochloric acid solution. And in the second half cell, the same hydrogen electrode can be set up just by bubbling hydrogen gas at P2 pressure. So the electrode cell can be represented as platinum, which is in contact with hydrogen gas at P1 pressure, that is in contact with the HCl solution. It is an electrolytic solution here. And in the second half cell is hydrogen gas at P2 pressure, that is in contact with the platinum electrode. Second type of concentration cells are electrolytic concentration cells. The second point is in electrolytic concentration cells. Here there are two half cells having identical electrodes dipping into solutions of same electrolytes but of different concentrations. The electrical contact between the two half cells is made through salt bridge, indicated by two vertical lines in the cell representation as shown below. So here in the first half cell, zinc is placed in its salt solution having the concentration C1. Then in the second half cell, the zinc is also placed in zinc salt solution having the higher concentration, that is C2. The cell representation can be written as zinc is in contact with zinc 2 plus in its salt solution having the concentration C1, and there is a salt bridge which connects between the two half cells. There is a double vertical line you need to write. After this, the second half cell is zinc ions. There is a salt solution that is in contact with zinc electrode. The electrode reactions are, in the first half cell you can expect oxidation, in the second half cell you can expect reduction. So first half cell acts as the anode and second half cell acts as the cathode. So therefore the reaction at anode can be written as zinc undergoes oxidation, that is Zn gives Zn2 plus 2 electrons. These 2 electrons will consume by the ions of zinc in the second half cell. So there it becomes neutral. The cell reaction can be written as Zn2 plus of higher concentration gives Zn2 plus of lower concentration, that is C1. The reaction is merely transfer of the ions of the metal from a solution of concentration C2 to a solution of concentration C1, that is higher concentration to a lower concentration. The EMF of the cell is given by E cell or EMF equals E right minus E left, that is E cathode minus E anode. The value of E cathode, by knowing Nernst equation, so using Nernst equation you can write E cathode as EC equals E naught plus 2.303 RT by NF log of C2. Similarly, E anode is can be written as E naught plus 2.303 RT by NF log of C1. So the EMF of this cell is given by 2.303 RT by NF log of C2 by C1. At 298 Kelvin, the value of 2.303 RT by F equals 0.0591. Therefore, the equation can be written as EMF equals 0.0591 by N log of C2 by C1, where N is number of electrons involved in the cell reaction. Here, E naught is constant for both the electrodes, so these two gets cancelled, so it remains constant. Since the electrodes are made with the same metal and the same type of salt solution being used. Then the application part, there is a determination of solubility of sparingly soluble salts using electrolytic concentration cells. The solubility of a sparingly soluble salt like silver chloride can be determined by constructing a concentration cell is shown here. Here, the first top cell consists of silver electrode which is in contact with freshly prepared AgCl, and that is in contact with 0.01 and KCl, and there is a double vertical line that indicates the salt bridge which connects between the two hop cells. It helps for the electrical contact between the two hop cells. Then in the second hop cell, the solution contains 0.01 and silver nitrate that is in contact with the silver electrode. Here AgCl is freshly prepared just by adding few drops of silver nitrate to a solution of potassium chloride. So this forms a saturated solution of AgCl in KCl. Here silver electrode is dipped in it and coupled with the second half cell, that is silver ions which is in contact with silver electrode. This is a concentration cell with respect to silver ions. Therefore, EMF of this cell is given by 2.303 RT by NF log of concentration of silver ions in the right hand side cell, that is AgNO3, divided by concentration of silver ions in the left hand side cell, that is AgCl. At 298 Kelvin, the value of 2.303 RT by F equals 0.0591. Therefore, the equation can be written as 0.0591 by N log of silver ions concentration in the silver nitrate solution divided by silver ion concentration in silver chloride. Let us assume there is a complete ionization take place of silver nitrate. Then the value of AgNO3 concentration is 0.01, and the value of concentration of silver ions in AgCl is C. Then the above equation can be written as EMF equals 0.0591 divided by N log of silver ion concentration in AgNO3, that is 0.01, divided by silver ion concentration in silver chloride is C. That C refers to concentration of silver ion in AgCl. Now we need to calculate solubility product. The value of KSP is given by the product of the concentration of the sparingly soluble salt, that is silver and chloride ions. So the value of concentration of Ag plus can be taken as C, and the value of Cl minus the value can be written as 0.01. So the value of KSP is equal to C into 0.01. If you know the right hand side value, then it is possible to calculate solubility product. By knowing the value of solubility product, then it is possible to calculate solubility of this salt, sparingly soluble salt. That is, solubility of AgCl is equal to square root of solubility product of the AgCl. The unit of this is moles per dm cube. So with this I conclude